State the number of complex zeros and the possible number of real and imaginary zeros. Now looking at this guy, I notice that this is a 9th degree. That's awful. So I'm not going to draw that out or pretend to draw that out. No thanks. But what this tells me though, is that tells me how many complex zeros there are. Now, this is the way that these guys work. You will only, if you have imaginary zeros, you can only have an even amount. So what you do is you start with the bottom at how many possible imaginary zeros starting at 0. So we will say 0 imaginary. And just to be lazy, we'll let I be imaginary. If you're going to have 0 imaginary numbers or zeros, that leaves you with 9 leftover reals. Okay, and then you work your way up by even numbers. So that's a possibility. Here's another possibility. 2 imaginary, and let's just do this. You could have 2 imaginary, you can have 4 imaginary, you can have 6 imaginary, and you can have 8 imaginary. Okay, you can only have an even amount of imaginary numbers all the way up to the number of complex numbers that you have. Now that I said that we had 2, 4, 6, and 8, we subtract these numbers from 9 to find out how many possible reals we have. So if 2 of these are imaginary, that leaves us with 9 reals. If 4 of these are imaginary, that leaves us with 5 reals. If 6 of these are imaginary, that leaves us with 3 reals. And if 8 of these are imaginary, that leaves us with 1 real number. So we have 5 possibilities: 0 imaginary and 9 reals, 2 imaginary and 7, 4 imaginary and 5 reals, 6 imaginary and 3, and 8 imaginary and 1 real. And again, that's because this graph is going to look something like this, blah, 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 all those bumps. So at some point, this will cross the x-axis, but we just don't know how many times it will cross the x-axis. Fun stuff.